Okay, good morning, everybody. The recording is now on, and thank you for joining today's class. I have seen that you have submitted the CA1 despite your busy schedule, and some of you might be appearing for the GATE exam next week, and some of you has appeared last week. So my best wishes to all of you. Before we had a 1 week break, and before that we had 3 classes on this. So we were talking about nodes and links, and we gave you a general idea of communication networks. And we'll continue on that. Actually, we are now in module 2, which is computer network. Let me briefly talk about the objective of this module at first before going to the details. Well, in this module, we are going to take few classes where I will try to make you familiar with computer network. So of course, if there are CS people, it seems very redundant, these classes. But my idea is to make sure that no matter what your background is, you know a little bit of computer network, so that whenever there are some troubleshooting situations, like you are using a computer network in an organization, you can talk to your system administrator or network administrator in a much more technical way, instead of just saying that internet is not coming or the light is not blinking or something like that. You can probably do some basic troubleshooting yourself, and probably you can talk to them in a much more technical matter. So we need to understand how the internet works, but the internet is a big network of computers. So we will start with a bottom-up approach. Like, we will start with understanding how some small number of computers can be connected with each other, and then you can have a network so that you can exchange information among themselves. Examples are, like, suppose you are working on a project where 2 3 different uh, divisions has to be done by different people. For example, the design is being done by some person, the budget is taken care about by some other person, the debugging or some other things are being done by some other persons. Then you need to exchange these kind of things, and sometimes these kind of exchanges are not done on public platforms. Like, you might think that there is always Google Drive or something. Well, sometimes it's done on a specialized kind of environment as well as software, so to protect companies interest, as well as it is easier in those platforms. So if even if you don't require a big network, maybe you can require a very small network in your office. uh, Let us take an example of our finance department in NIT Durgapur. In NIT Durgapur, in the account section, we have a computer which records all the databases of the employees and the staff. Then there is another computer which is taking care of printing those salary slips and so on. So these computers need to be connected with each other, even if they don't need the connection to the outer world or the big internet. Still, they need to be connected with each other. So our approach in this module will be to understand those simple small networks fast. Like, suppose a person is starting with only 3 or 4 computers in his or her office, then how those network can be formed and how that works. And once we understand that, then we can understand how these small networks can connect to form a bigger network. For example, our accounts department, our administrative department, and our academic section can together form a bigger network. Then we will understand how these bigger networks can form a campus-wide network like NIT Durgapur, and these campus-wide networks together form a city-wide network, and then probably a state-wide as well as a country-wide, and finally the internet. So this is our approach to understand the bottom up way to understand the big network. If you start from the top, you will be overwhelmed by seeing the sheer amount of data and sheer amount of number of computers, how they are connected, and it is very difficult to understand how everything is operated. The other thing I want to talk about you is, when understanding networks, the philosophy is, uh, you probably know your neighbors and not more than that. If you want to know the whole thing, then your system will crash or you won't probably able to operate. What I mean to say by this statement is, when you are transmitting something far away, suppose you are having information at NIT Durgapur server, and somebody at New Zealand is probably going to access that thing. So of course there are many intermediate computers through which this whole thing goes on. So if you think that either the user at the New Zealand or the server at the NIT Durgapur knows everything about this transmission, then it is not the case. And ignorance is a bliss in this case. So the system is designed in such a way that the request for the NIT Durgapur page will be generated by the New Zealand computer, of course, but that will be transmitted to the nearest connection for the user. So the user in the New Zealand only understands that, okay, I have sent a request to my nearest service provider, and he will or she will take care of that. Similarly, when such a request after many hops come to NIT Durgapur server, NIT Durgapur server doesn't know how exactly it will pass through all the way. But it knows that if I send it to the BSNL server in Durgapur, probably they will take care of the rest. So this is how the whole thing is operated in a very distributed fashion. There is no centralized control, but connections are there, and it is done in a very distributed kind of fashion. Okay, so with these two philosophies in mind, like, we are basically trying to do some basic troubleshooting kind of thing and basic understanding, and we are also having a bottom-up approach. And finally, we are having something like, if you hand the baton to your neighbor, probably then it will be ultimately transferred to the ultimate destination. This kind of approach, we start our module 2, which is computer networks. Now, in computer networks, we have obviously computers and they're connected to each other, and the simple network that we form is called Ethernet. There is a age-old theory that the space was not void, it was filled with ether. It was something like many years ago. So that was a kind of a funny theory. But the computer, the mobile, the ECE, and the CS people are jargon-happy people. They try to dig up such kind of jargons, and they want to attach it to their networks to sound it catchy. So that's why when the term Ethernet came, they thought that, okay, it's something like ether is everywhere, so this network will be everywhere, and that's why they have coined the term. The same happened something like with Wi-Fi. These are some kind of catchy terms, but they signify almost nothing, or probably there are better technical names for them. Anyway, so I will be in my next class, that will be on Wednesday. I'll be specifically talking about Ethernet. But before talking about Ethernet, let us, or that is more popularly known as LAN, or local area network in some cases, or more technically known as LAN. So this Ethernet or LAN I will be talking about on Wednesday. But today I will try to link up the idea of nodes and links, which we discussed 1 week back, with computer networks. And for that, I need to describe two things. The first thing, I probably will share my PPT screen now, and probably you can see it. Fine. So I hope you can probably see a diagram opened on my PPT screen. There are certain blue circles and certain blue arrows. I hope you can see that. Okay, so my point of sharing this thing is, we are trying to relate the idea of nodes and links, which we describe to, which we use to describe any network, to computer network. Well, if you have forgotten, let me just remind you that every communication network is made up of nodes and links. Nodes are two types. One is communication node, one is terminal node. Terminal nodes are those which generates or consume information, and the communication nodes are intermediate nodes which only transfer the information from one part of the network to the other part of the network. The links are the connections between the nodes. So let's now understand the connection between nodes and links, and that has a special name in communication networks called switching. Now, when we hear the term switch, we generally think of an electrical switch, which is on or off. That's fine, but the term switching in general has a more general meaning. Let me tell you how. Well, when we hear the term switch, and as an electrical switch, it has two choices. Like you can make it on, or you can turn it off, turn it on or turn it off. So there are two choices. In general, switching means having multiple choices, maybe two or more than that. So switching is actually considering a set of nodes and links so that you can set a path between two nodes. I explain once again. Like suppose in a network, there are many nodes and many links interconnected in a fashion like whatever I have shown on this screen. Now, suppose you have to connect two nodes, and you can do it probably by choosing intermediate nodes and links in many different ways. So the choice or the selection between such possibilities is known as switching. So suppose in the network that I am showing here, there are 6 nodes, 1, 2, 3, 4, 5, 6, and they are connected in this fashion. Not every node is connected to every node. Probably suppose such kind of connection is possible. Now I give you a task that we want to connect node 1 to node 6, or rather I want to go from node 1 to node 6. If I consider myself as a packet of information, so and we consider that these 1, 2, 3, 4, 5, 6 are something like road crossings, and these arrows are roads. So you can consider that I am trying to go to node 1 to node 6 via these different routes. So how many such possible routes are there? Identify them and write in the chat box. I want to go from node 1 to node 6, and what are the intermediate nodes I can choose, or what is the path I can choose? Like for example, the fast path you can write as 1-4-5-6, something like this. So in this way, please write all possible paths between node 1 and node 6. Yes, Mohit, that is one possible, and I want to know all other possible paths as well. Yes, 1, 2, 3, 6, right? And 1, 2, 3, 6, yes, of course. Yes. So we have got 3 possible paths, I guess. And that too because I think the link between 4 and 3 I have shown as unidirectional. That is as if we can only go from node 4 to node 3. The arrow is in such a way. Suppose the arrow is bidirectional, then probably there can be another path like 1, 2, 3, 4, 5, 6, something like that as well. It depends on the type of the arrow. Okay. So that's the idea of conveying the idea of switching. Like while you are connecting between two nodes in a network, there are multiple possibilities of choosing intermediate nodes and links. Such kind of choosing action is known as switching. Now let us try to understand how the switching was done in the earlier days, and then probably I will tell you what revolution the computer networks has brought. Well, we talked about evolution, and I'm trying to link you with the evolution class which we had earlier. We said that the earliest possible communication network was telephone network. Yes, that was the case. And in telephone network, what is the need of switching? Let us first understand, and then I will try to tell you how the method of switching was done. Well, I probably described a little why it is the need of switching. The idea is, suppose the head of the mechanical department is trying to call the head of civil department, and this is a local call, and that call has to be going through the telephone exchange inside NIT Durgapur. NIT Durgapur has a telephone exchange. Telephone exchange is something like an intermediate node. So you can consider this situation as there is a node 1, the node 2 is the telephone exchange, node 3 is civil department HOD's telephone. So node 1 is mechanical department HOD's telephone, node 2 is exchange, node 3 is civil department HOD's telephone. So the choice of path is very clear. It is like 1, 2, 3 always. Like the connection should be made from the mechanical HOD's telephone to exchange to civil HOD's telephone, something like this. Very clear, no ambiguity, fine. Now, suppose the mechanical department HOD is, after talking to his colleague, he is trying to call somebody else in Delhi. Now, the choice is not that obvious because there is no direct connection between that telephone to his telephone, his friend's telephone, who is probably at IIT Delhi. Suppose our mechanical department HOD's batchmate is in IIT Delhi. He wants to invite him for some program, joint program being done with civil department. Now, this connection is not so simple because there is not a direct link from our NIT Durgapur telephone exchange to IIT Delhi's telephone exchange. There is no such link because there are hundreds of such organizations, and you cannot make sure, or sorry, probably lakhs of such organizations, and you cannot make sure that everybody is connected to everybody else. And probably I have told you in this class that what is the problem if you try to connect everybody with everybody else, that we discussed in point to point via shared links. So what is the case? Well, first of all, once the number is dialed, the NIT Durgapur telephone exchange finds that it is an outstation call. It is beyond my capability. So once the dial number reaches the Durgapur telephone exchange, the NIT Durgapur telephone exchange simply reroutes the call to the BSNL exchange at Durgapur. It transfers it to Calcutta because it finds that it is outside state. Now, there is probably a direct connection between Calcutta and Delhi, but not to IIT Delhi. So the Delhi main exchange is connected, and then from Delhi main exchange, the IIT Delhi exchange is connected, and then finally to the mechanical department of IIT Delhi, something like that. So there are multiple such paths, and all these paths should be established before the call can take place. So while the mechanical department HOD is dialing the number, that number is passing through all these exchanges and the path is getting set up. So as soon as you start dialing the number, okay, 01124161069, you are dialing these numbers. During this dialing, or just you hit the call button, once you hit the call button, all these things are taking in progress in a very fast and efficient manner. The number goes to the nearest exchange, then it sends it to the other exchange depending on the number, and so on. All these connections are established. So such kind of path establishment is also called switching, and this switching can be sometimes be tricky because there might be multiple paths existing. Like suppose you want to call somebody at IIT Mandi, not IIT Delhi. Now, when you are trying to call somebody at IIT Mandi, well, the nearest exchange is probably in Dehradun, but Calcutta might not have a direct connection to Dehradun. So there are two ways of reaching Dehradun. One is via Delhi exchange. Delhi exchange probably is connected directly to Dehradun. Other one is via Lucknow exchange, which is probably connected to Dehradun. It is something like planning your journey. Like you are going for a journey and which route you are going to take. Just as simple as that. You can consider this as routes. So there are two choices. Either you can contact the Delhi exchange or contact the Lucknow exchange. Which one you contact? Probably either of them, depending on the current rush. Like if currently the Delhi exchange is very busy, then probably you first knock the Delhi exchange, are you very busy? Delhi exchange says, no, you can send me another call. Then you send it. If the answer is no, I am very busy, please try somebody else, so then you probably reroute the call through Lucknow exchange. So there are possibilities like this. Well, so I was talking about how this whole thing evolved. Well, in telephone exchange or in telephone communication, such kind of switching was done before the call was set up. Like once you dial the number, the path is set up. So it is not the case that during a call from NIT Durgapur to IIT Mandi, in between some path setup is getting done. No, it's not never possible. Once you dial the number, everything is set up by the exchanges, and then the other person gets the ring, then the other person picks up the phone, and then the conversation starts. So once the conversation starts, before that, this whole setup, this whole path planning, route planning should be done. So that switching is done before the conversation. And during the conversation, such route cannot be changed. There is no possibility. Like the exchange cannot tell that, hello, mister, you are talking for 3 minutes. And I find that now Delhi exchange is now relatively free. So would you mind cutting the call and probably redialing the number so that we can connect it to the Delhi exchange? So that kind of thing never happens. So this was the situation in the early days of communication, where the telephone calls were the only calls which were, or only means of information exchange for a long distance network, and the switching was all such kind of thing. Like once you dial a number, you have an end-to-end connection established, and that kind of switching or path planning is retained till the conversation ends. Of course, whenever the mechanical department HOD hangs up his phone and makes a new call, probably to next time to IIT Bombay, then obviously a new path planning is required. But unless he hangs up, the path that was established between IIT Durgapur and IIT Mandi is retained during this whole conversation. Whether he is talking for 1 minute or whether he is talking for 1 hour, doesn't matter. Okay, so this is a switching mechanism which is connecting an end-to-end kind of thing. And when we have such kind of end-to-end connection, we say that it is a circuit or it's a connection which is maintained. So such kind of switching is known as circuit switching. On the other hand, when computers came, then the computers initially used such kind of setup. It was like the NIT Durgapur is trying to send some file to IIT Mandi, and there is a dedicated connection through a telephone line, and that connection is established till the exchange is finished. This seems okay at the beginning, and it was actually, but soon it was found that computer exchanges data in a different way than telephones. In telephones, when you are talking to each other, you expect that line to be live at all the time, and generally you are not taking the session very long. I was just curious, what is the longest telephone session you might have encountered? So please write in the chat box what is the average duration of a call you think you are making, and what is the longest duration of a call you have made in minutes. The average duration of call that you generally make, and what is the longest duration of call you have made. I just got last time answers from Mohit and Akash. I hope everybody else is there and this doesn't require any thinking. So what is the average duration of call generally you make in minutes, and what is the maximum duration of call you have made that you can remember? Okay. 30 minutes only. Okay. Anyway, I agree. Fine. So I don't remember what was the longest call duration because I slept midway. So anyway, probably it was on for much of the time left in the night. So what I mean to say is, in telephone communication, generally the sessions are well defined, and you generally put up the session after a certain time. But in computers, It may not be the case. Just think about downloading a movie from a torrent. When you are downloading a movie through a torrent, then probably you keep the computer running for a long time. If the network is quite fine and the torrents are probably very near to you, I hope everybody has downloaded a movie through torrents at some point of time. So probably you keep it on. Like I remember 3 days back, I was downloading a movie, The Secret Life of Walter Mitty. And when I was downloading, the link was very slow. I kept it on and I went for some administrative work. The PhD admission was going on. And when I came back upstairs in my room, it was like 3 hours or so. The movie has been downloaded. So my point is, in computer, probably the sessions are quite longer, and not all the time you are getting something, because the server at the other end probably is busy, so it is not going to give you something. Also, probably you are doing something, a chat session or something, where you don't have much to say in between. Like suppose there is a project page open and two persons are working on a project. So unless you think of something or you come up with something, you have nothing to report. So in computers, the idea of communication is much more discrete in nature. That means there are long gaps or pauses between something useful to communicate, which was not the case in telephone. In telephone, you generally speak, you expect the other's response, and then you stop the session. On the other hand, in computers, it's like you send a file, and then probably there is a 20-minute gap, and then probably you send a file again, and that's how the sessions are long, but there are long gaps in between something useful being transmitted. So when telephones were the only means of computers to communicate, that's what I discussed 2 weeks back, that in early days we had two computers connected via telephones. So the telephone lines were remaining engaged for a lot of time, but without transmitting anything useful. And people found that it is not a very efficient way. So we should probably change the idea. We should probably think from a different perspective when computers are communicating with each other. We should not think in such a way like the telephone networks operated. So what these people came up with is that let us have some intermediate nodes or communication nodes, and this communication node can share the link between many computers. So it's like, okay, fine, now the computer one is active. So it's like, suppose, let us go back to the screen that I'm sharing. Suppose there is node number 3, and node number 3 is getting information from node number 2 and node number 4, and it has to transmit some information to node number 6. Now, in the earlier situation, if node number 3 was taking some information from node number 4, it will deny any connection from node number 2. It will say that, no, I am already taking a session, I cannot accept you. But in this new connection strategy, it will say that, okay, I will accept you both, because it is very unlikely that both of you are going to probably send me at the same time, because you have long gaps in between. So I will accept both 2 and 4. And sometimes when I get the information from 4, I will send it to 6. And sometimes I will get from 2, then I will send it to 6. And in the meantime, if I am free, probably I can take information from somebody else as well. So node number 3 is not dedicated anymore. In the earlier case, the paths that you have written in the chat box were all dedicated. So once the path is established, that path is dedicated, and those nodes and links were not used for that session, at least, to or it is not shared to anybody else. But in this scenario that I just explained here, node number 3 is shared, and it is sometimes taking the information from node 4 and node 2. Now, if suppose there is a very rare occurrence that both the node 4 and node 2 is transmitting at the same time, then probably node 3 keeps the thing at the buffer and probably sends it at a suitable time. Now you see, this is possible because in computers, most of the communications are non-real time. That means you don't have to transmit the information at the same instant. If we are thinking about downloading through a torrent, it doesn't matter whether you are taking the information at that millisecond or after 2 milliseconds or something like that. A small amount of delay doesn't matter. So computer networks are fundamentally different from telephone networks. Computer networks can tolerate delays. Computer networks have long gap between information transmission, and the sessions are generally longer. So these characteristics make the computer networks different from telephone networks, and that's why this new method that I described is known as packet switching was used for computer networks. So computer networks operate in a fundamentally different way from telephone networks. Earlier, computer networks were solely dependent on telephone networks. So computer networks had to go by the switching method that the telephone networks used. But nowadays, computer networks have become so powerful and telephone networks have taken a backseat. Now, interestingly, what happens is now there is no telephone network dedicated, and rather the telephone networks are trying to adapt themselves to the strategy of the computer networks. An example, well, probably from 4G plus onwards, you have certain SIM cards where you, unless you turn your data on, you cannot make a mobile call. So that means a phone call is treated as a data transmission session in those mobile phones. So such kind of things are now the case. Like the situation has been reversed, I should say. Like the in the earlier days, I mean 60 years ago, the computers were lame and they could not do anything without telephone networks. Now the situation has reversed. Now all the networks are made for computers only and computer like devices. Whatever device we use, a smartphone or something, everything is more or less like a computer. So they are designed on such a way. This is called IP based network or internet protocol based network. So for these IP based networks, we are now trying to push the old telephone kind of things as well. So that is what the difference between circuit switching and packet switching is all about. A final word about the circuit switching and packet switching is something like that. I'll tell you a story that 3 days back I was going to NIT Durgapur from my residence. I generally stay 15 kilometer away from NIT Durgapur campus. Now I generally take the GT road while I'm traveling from my place to NIT Durgapur. But what happened was there was some rally or something. So there were some traffic police who were diverting the traffic. So some traffic was being allowed to take the same route and some traffic were diverted through the city center route. So this is a perfect example of packet switching. So packet switching is like efficient utilization of resources. Wherever you have a free route, you can probably take those things. On the other hand, 1 week back, I was stuck. I was coming back from Calcutta to Durgapur. I was stuck in a train because there was some problem with the track. Well, in a railway track, you cannot shift the train to other track because it was midway, like it was not a junction point or so. So I was stuck there for around 1 hour or so. So that's a perfect example of circuit switching. Like you have a dedicated track and you have a dedicated train on that, and that track is probably dedicated for the train. And although there is other resources empty, like there was other lines free, but you cannot reroute the train to the other track. So that's an example of circuit switching. Okay, so we have enough of circuit switching and packet switching. Now I will tell you another interesting fact about packet switching. The packet switching has an interesting thing called store and forward transmission. Now, what is store and forward transmission? Well, in store and forward transmission, what happens is that we can transfer the information via storing and the information in the intermediate nodes and then forwarding. That is called store and forward. Well, that might not seem very revolutionary at the beginning, but let us do some simple calculation and then probably we can get a glimpse of this. Okay, so in this slide, I am showing you a simple network with 3 nodes. There is a fast node, which is the source. There is an intermediate node, which is a communication node, and then there is another terminal node. The link between first 2 nodes is having a capacity of 1 Mbps. I hope you know what 1 Mbps is. Mbps is the data rate speed of transfer capacity of this link. The second to third node capacity is also 1 Mbps. If you are wondering what happens with the propagation, like how much times it takes to actually physically propagate the packet from one end to other end, then I tell you that that is very nominal as far as small distance networks are concerned. I'm not talking about satellite networks, but small distance networks, because the electromagnetic waves travel at the speed of light, which takes almost no time. Even if you are carrying the signal through wires, they are being carried at a rate of 50% or 40% of the speed of light. So that's still pretty fast. So I'm not talking about how much time is required for taking a packet from one place to physically to other place, but rather I'm just talking about the capacity. Okay, so my question to you is, suppose in the first node, that is the leftmost node, we have a 60 MB packet. I'm writing on the chat box 60 MB packet. Suppose I have a 60 MB packet on the leftmost node, and that packet has to be fast transferred to the intermediate node. And once the whole packet is in the intermediate node, then we can only transmit it further to the third node. So after how much time I can see the packet at the third node? I repeat my query again. We have a 60 MB packet to transmit over such a network. The 60 MB packet is in the first node. We have to transfer it to the second node. And once it is fully received in the second node, then only we can go on transmitting it to the third node. How much time we require to transmit it to the third node? Okay, so I have got answers from Akash. I have got answers from Nilabro. Anybody else having any difficulty in understanding the questions? If you don't want to do the sum, that's a different thing. But anybody having any problem with understanding the sum? Okay, 2 minutes, 2 minutes. Great. So the calculation is pretty simple. 60 MB packet, 1 MB you can send it per second. That is actually the transmission time required. There is a slight difference between propagation time and transmission time, but it's an open elective course, and I don't think I should go into that details. Anyway, so fine, we have a 60 MB packet. We need 60 seconds to transmit to the second node, and then to the third node we need another 60 seconds, and after 120 seconds or 2 minutes we get it there. Fine. Now let us propose a second technique. Let us, I am writing in the chat box, divide the 60 MB packet into 60 packets of 1 MB each. This is my new scheme. My new scheme is divide the 60 MB packet into 60 packets of 1 MB each. And instead of sending the big packet at one go, I am sending the packets one by one. So what happens is that when the first packet is transmitted from node 1 to node 2, it is received. And while the first packet is being sent from node 2 to node 3, the link between node 1 and node 2 is free, so it can carry the second packet. Let us try to understand the new scenario once again. What I mean is, in the previous case, when the 60 MB packet was being transmitted from node 1 to node 2, the link between node 2 and node 3 was idle. But in this new case, what I am doing is, I am doing it in tits and bits, and the first packet, when it is being transmitted from node 1 to node 2, of course, the node 2 to node 3 link is not doing anything. But while it reaches the node 2, the first packet is being sent from node 2 to node 3. And during this time, the second packet can be easily transmitted from node 1 to node 2. Now, with this new scheme, how much time we need to transmit the whole 60 MB thing from the left end to the right end? Okay, great. So we have got answers, and probably you have got the idea as well. That is, we need only 61 seconds, because in every 1 second a packet is being transmitted from node 1 to node 2, and after 2 seconds the first packet reaches there. So after 2 seconds, when the first packet reaches there, in every new second another packet reaches there. So there are 59 more packets. So after 59 more seconds everything will reach at the end. So this is how I am trying to convey the power of store and forward transmission, which shows that if you divide a very big data into smaller packets and use the intermediate nodes in this way, then you can reduce the end-to-end delay or latency, which is generally the major issue in a network. So this is one way, but of course there might be issues with such kind of things. What happens is that uh, I tell you the idea of such kind of dividing. If you are having a long queue of cars, then you can reroute the packets in different ways. Like in the previous example I said, some cars are rerouted through the city center route, some cars are through the GT road, and so on. That's possible. But suppose you have a long goods train, and you want some bogies of that goods train to go through this route and some other bogies to go through that route. Well, you cannot simply do that, because you need an engine or a guard compartment along with such bogies as well. So what I mean is, when you are dividing the packets into 1 MB, the situation that I shown was very simple, but it is not actually the case, because you need to add an engine and a guard compartment as well. What are the engine and guard compartments? Well, generally you need to put some header and footer with every packet, so that those packets can independently travel. Because if you simply cut a file part and you transmit through a network, the network won't understand anything, or probably how it can go through, how it should be propelled, and it is not clear. So the actual amount of data will not be exactly 1 MB, it will be slightly more than that. Still, we are going to get the benefit. The benefit will start to reduce when you are making the packets too short, because when you are making the packets too short, the packets always have some fields which have some information of address and so on. So when the data part of the packet is much less compared to such ornaments, it's like you are sending a elastic girder with Amazon package. The Amazon package is this big, and within that the actual content is very small. So that is not economic anymore. So there is always in a network an optimum packet size. A very big packet is not good, you have already seen. If you have a big amount of data, then if you want to send it, then it will cause unnecessarily latency or delay. Again, if you are trying to break the big thing into very small packets, then the packaging is what probably will cost you more rather than the actual content. So then also you are on the losing side. So there is something like optimum, like not too big, not too small, that amount of data fitted in the packet, and that should be optimal for the computer networks. So with this, I stop here. It's 9:45 already. Let me just review what we discussed today. We discussed today two important concepts. One was the type of switching, circuit switching and packet switching. The second one is store and forward transmission. These two things make the computer networks different. So with these two things in our background, in the next class on Wednesday, we'll try to understand how small number of computers can be connected together and how they can form a small locality network. Thank you all. I stop the recording now, and if you have any queries,